Hello everyone. Today we're going to be looking at calculating present value. And calculating present value is actually using the formula that we were using yesterday. I'm going to write this up here above it. So previously we were using the A equals P times 1 plus R divided by N to the power of N times T. That was the formula we were using on Monday and Tuesday. Today, we're going to use a reworked problem that, because it's actually the same equation as this, but right now in this equation, we have our P right here, and that's not very useful to us. So that means we need to, or if we want to know what P is, because if we're given a situation where we know what the future value is, what the rate is, what the compounding periods are, and then what the time is, we want to know then how much do we need to put into that account at the start. So this is important for situations where we are looking for how to find P. So really to do that, we just need to get P by itself, and really this whole piece can almost be considered its own piece. And what we're going to do is we're going to divide it by 1 plus R over N to the NT. We're just going to divide by that whole piece. This will cancel out this completely. And what happens on the other side is you end up with what you do to one side, you have to do to the other. So we do 1 plus R divided by N to the NT. So that yields us a final equation of P equals A over 1 plus the rate divided by the compounding period to the power of the compounding period times the time. So now we have a working formula for P, where all we've done is we've taken the second half of what the future value equals, and we've divided it over on the other side. So using this in practice is actually very similar to what we were dealing with the other day, where you kind of plug in the numbers and you do the calculation. So down here, we want to know, it says how much money should be deposited a day in an account that earns, that should say earns 6% compounded monthly, so that it will accumulate $20,000 in 5 years. Now, we're going to be using this formula here because it says how much money should be deposited today. So that's why it's called P, the present value, sometimes called the principal. You hear it called both ways. Since it wants to know how much is going to be happening today, we know that we're using this formula, we're looking for P. And the numerator, we have our future value, how much we're going to be earning. And in this case, we want to know how much we need to put in if we're going to earn $20,000. So our future value for this is going to be $20,000. Down below, we have 1 plus the rate over the compounding period. So our rate for this one is going to be 6%. So we're going to call this 0.06. And then the compounding period, it says it's compounded monthly, and since there are 12 months in a year, that means our compounding period is going to be 12. Then outside we have that N times the T. Our compounding period is still 12, still talking about monthly. And then it says it happens in 5 years, so our time is going to be 5. Now, the one thing that you really need to be careful on these is when you're plugging them into a calculator. So, pull out my calculator here. I have this future value of $20,000 in the numerator. I'm actually going to leave that alone for now. So what I'm going to do here is I'm actually going to do some of the calculations piece by piece. So the first thing I'm going to do is I'm going to do this 12 times 5. And this 12 times 5 is going to end up giving me 60. So I'm going to write out what I'm going to keep over here, which I'm going to keep that 20,000. These parentheses will still be here, but I'm going to do the math that's inside of them. And then that's going to be raised to the power of 60, because that's that 12 times 5. So this is the 12 times 5, it became 60. Now inside here I have 1 plus 0.06 divided by 12. You can actually just type that in. Usually I do fractions in parentheses just to be safe. So I plug that 1 plus 0.06 divided by 12. That's going to give me 1.005. So I'm going to go ahead and write that inside of the parentheses here. So this is going to be 1.005. So now I have something that's a little bit easier to do some math with. So we have 20,000 divided by 1.005 to the 60th power. So what I'm going to do is I'm going to take that 20,000 that's in the numerator, plug in my calculator. I'm going to divide, and then I know I have 1.005 to the 60th power. I'm going to go and put this in parentheses. You don't necessarily need to on this one. And since it's to the 60th power, I'm going to use that caret button. It's going to give me a caret, looks like this on the calculator. And then I'm going to type in 60, close that parenthesis. So I have 20,000 divided by 1.005 to the 60th power. Hit enter. That's going to give me an answer of $14,827.44 because I'm going to round it off at that point there. So we're going to go ahead, cut that off, and we'll say our P is $14,827.44. That's how much we'd have to put in at the beginning of the 5 years to get that $20,000 at the end of the 5 years with a 6% interest rate compounded monthly. So this would be our P. If you have any questions about it, please get with me in class.